Hey everybody. Okay, so yesterday we finished up the camera. Or I finished up the camera, and today I'm starting animations. And animations is very, very tricky because just like there's so many reasons why animations is very, very tricky. And there's probably like three or four concepts that are we have to sort of conquer before this will even before you can effectively code like anything sound anything time related, so sound stuff and video stuff, audio stuff and video stuff, particularly rendered video. It's really important to understand that some concepts. And the first concept you have to understand is that, like, if you were brought up in some other, if you learned some other coding language, like I learned, my first language was BASIC. And in BASIC, they had a clock, and that clock was kind of like when you did animations or you did anything like that, you went off of that clock. And so the clock controlled the amount of time. So if you're saying, hey, this is where this thing is supposed to be at 1 second, then when 1 second came along, it was in that spot. And so then you're like, okay, well, so every time this clock moves, it's gonna, let's say it moves every 100th second, move it zero point 0.1 pixels or whatever, and you would have this nice little animation that was nice and smooth across. But JavaScript does not work like that. JavaScript works on something called a request animation frame. And a request animation frame is something that most people, most Americans that speak sort of the same sort of version of American English that I speak, which is kind of like from a background of like sort of people who like not not super influencers or build people who build like processes, but more like people who like do stuff. So like both my parents were, my dad was an engineer. They like did stuff. They actually physically did stuff. So like the word request means, has a very specific meaning in my version of English, and that's like something that I request be done. It's like a verb. But like there's a whole other group of people who they were raised up like in more of a structural environment or more of a influential environment, and a lot of times for them, a request is not something that they do. They don't request things; they attach things to requests. Like there's a request form, and they in their request form that is a request that's going to get like 1,000, let's say, widgets, and then they want some, water along with that. They add three things to that request. So when you see request animation frame, what you're thinking, if you're from sort of my sort of version of American culture, you're thinking there's like a request, like you're asking, you're requesting for something, you're doing a verb, and that is not what you're doing. You're actually saying, I want to, I on the next animation frame, I would like you to add this logic. And that is really weird to people. And the request frames don't happen at the exact same time. So in this, I'm showing right now that 190-ish seconds have passed, and that the last time it was either 0.033 or 0.034 times seconds between this request and the last request. So it's not the same amount of time. But one time it actually took 0.149 seconds. And so this time, 0.033 or 0.034, your eye can't perceive it. So I'll explain what I've done later, but if you hit this in a second, but if you hit this, see, you see this is moving around, and actually you can see that it is not smoothly moving. It's actually moving along. And that actually, you rarely can see this, but you can actually see that it is not a nice, smooth motion, that it's jaggy. And that's because these requests are coming in, and they're coming in really slow. And so, and then this can be really, really hard because a lot of this has to do with how many cores your computer has. So, like your experience as a developer, like if you have a quad core CPU, you about 25% of your CPU processing power will be dedicated to this browser. But like let's say you have a pretty beefy machine, 25% of a pretty beefy machine can do a lot. But let's say you have a 16 core processor. Well, then you have one tiny little core that's trying to handle all this, and it's probably going to be very, very jaggy, and probably always very, very jaggy, because that one little 1/16th of a 1/16th processor probably won't be able to process this very well. And then if you have a single core processor, like it wouldn't really matter how beefy it is, because this is going to be affected by other programs that are running on your machine. So if you have some highly intensive process running on your machine and you only have one, it might take 100% of your CPU at times. And then what happens is you might actually, even though it's a monster machine, you might actually see differences. So that is sort of the thing that's going on there. Okay, so I'm going to take a step back here and just kind of show how I accomplished this animation. I did this because the spinning is actually not conducive to seeing sort of this jaggy sort of behavior that we're seeing, and um, that is, how that works. But anyway, so I'm going to come in here and let's see, what did I do? Okay, so I did nothing in there. All I did is remove an extra line. And then in the HTML, I moved it to where the mesh is in front again, because camera was in front, and that's convenient. So this, okay, so I don't want this. This is actually, I think, let's do that. Now, I think, yeah. So that was like for tomorrow's lesson, and I was just messing around. So it is a lot smoother now, but whatever I was doing before was actually causing it to be pretty jaggy in the move. Now it's like I can add meshes. And when I add them, before what was happening is they were all getting reset, and that's actually an interesting thing. But anyways, so let's see what's here. Oh, okay, so this code is just so that these will be randomly different colors. And I also changed the height and width so that they didn't kind of look like they were bouncing into each other. But as you can see, they're coming in and they're kind of slowly working their way up. And then when they get to the top, they end up back down here again. And then when they get going deeper into the Z position. So you can see like this very first guy is moving around, and this is all jumping around. And if you wanted to fix this jumping around part, you just would set the number of like to hard code it to 4 digits or something like that. And actually in my console log I show how to do that, so I'll mention that when I get there. So over here we create a 3 clock. I'm hoping this 3 clock has like the ability to reset. Let's see, clock dot reset clear. I don't know. I'm hoping that there'll be a way for that clock to go to 0. So there's an advantage of using that over just using the JavaScript state functionality. And then this is the time that was run, that the request animation frame was run last time. And then this is the difference and the biggest difference. And so all I'm trying to get across here is, or in a second, I'm going to show you that the time is not consistent. And I think I've already demonstrated that, but let me, this I set the animations to true by default for my convenience, so I don't have to keep clicking over there and to turn it on. So basically I get the current time, the amount of time that was elapsed. So let me show that. So that's this. So we've gone for 145 seconds. So then this is the difference between this time and the last time. And then I console log the current time and I fix it to 3. So when you look at the console log, that is staying a consistent length, and we don't have all the jagging jumping around that we see there, and that is sort of the point to that. Let me pause this. This is going to take a little longer. And so this is where I determine what the biggest difference we've ever had, time difference we've ever had was. And so far, the biggest is a quarter of a second. Oh, now it just happened 2.27 seconds. And these sort of big gaps like this is why it'll get jaggedy from time. And this is why literally most efforts I've ever seen, whether people were doing it for fun on the side or in a professional environment, have failed horribly, because eventually, as you start adding things and things start happening and you're trying it on different computers and different devices, these things just start getting ridiculous, like where you can't ignore it, how inconsistent the popping around is. Um, so we'll so anyways, so this is sort of just a bunch of code just to calculate the information for the console log. And so this is a bunch of code that's just setting boundaries so that when we add these meshes, as they move around, they sort of move so we can kind of watch what they're doing. And there's really, like, it might be interesting to you, it might not. There's just no telling, but it's not. It's throwaway code. So both of these sets of code are just pure throwaway code. This is the initial mesh rotation that's just happening on everything. This is on every animation frame request. And then this is where we get the current mesh so that we can figure out what its position should be. And this is where we're setting them. So this, honestly, is exactly how every professional and hobbyist animation I've ever seen done. This is exactly how I've seen them done every single time, where basically there's this animation callback and you get to the end and it calls itself again. And um, and now this is all happening. This is a little different than like if you were doing vanilla JavaScript, because they in 3JS they've insulated that away from you. But typically what it is, you'd get to the very end of this and then you'd make a call for the next request animation frame to rerun. So they're kind of internalizing that and doing that in here. So you're saying it's basically making all those calls. Like I said, the problem is that this is the only language I know of that does it this way, and it's not the same size, so it will look screwed up. And so those are, and it's totally, it can be very exacerbated based on like the number of cores your computer has and things like that. So it's a shit show. It's just a shit show. So anyways, that rant is done. Okay, so now I hope all I wanted to get across is these times are inconsistent and you can't build a good animation, a reliable, good animation in this way. That's all I was trying to get across there. Okay, so there's another thing I need to get across. Okay, so you see this, and this is all popping around. If you want to fix it, you could just do those like I mentioned before. But now let's go over here. This is not updating. This is updating. Oh, hitting the wrong thing. This is updating. This is not updating. I'll leave it up to you. I will reveal tomorrow. There's like 3 major things going on that are preventing this, and it is one of the things that if you ever really want to sort of take your JavaScript level skills to the next level, you have to grasp this, or you have to grasp these issues. But the idea is that, and the way Angular has done this, like, so if we were in a jQuery, right? If we were doing jQuery or any of the traditional like libraries they kind of just extend JavaScript, like that's how I differentiate between a library and a framework. So if you have a library that just extends JavaScript, this wouldn't be updating either. Basically, this and this would be acting very consistently, and they would be acting consistently um, for a very specific reason. But you would not be able to see these. This would be at this if we were in jQuery and all that coded the way I've coded it would be acting just like this. Now, if we were in React and anything that kind of is set up like React with a state and that you request updates to the state and then the state gets updated and all that, then this would be acting the way this is acting. Like this would be updating as appropriately the way this is. So I will fix that tomorrow so that they both update. Now, one last thing. I do not actually want this, right? This is not a good thing because what I really want, I don't want to lose what the user set up, right? So what I want is to go a different direction. I want to, when the animation callback happens, when the request frame is executed, um, what I want to happen is for it to, for JavaScript to determine how much time has passed and then place the the item appropriately. I don't want it to just willy-nilly move it a certain amount, which is, I confess exactly how you would do it in any other language. You would figure out how much time elapses between the CPU cycles and then just say, okay, if I want to move it three units per millisecond or 10 units per millisecond, whatever, that's how you would control it, but you can't control it this way. So what I want this to do is something more along the lines, instead of just like adding, what am I doing? I'm adding the move distance of 0.1 on every cycle. What I would want to do is say, oh, how many milliseconds has passed since the last time? Okay, this is where it goes now, right? And that would give me the appropriate distance, and place everything properly, and it wouldn't be all jumpy anymore. And the only way it would jump is if something happened to the computer that caused, whatever these rare events are that we're seeing here that causes a quarter-second delay between, but it will end up in the right place, and in all likelihood for your time, and your brain would just fill in the blanks for you, but so anyway, so tomorrow I'll have it to where this is updating that, and I think there's three basic concepts, things that I have to fix to get that to work, and one of them is a foundational concept, and that's all about whether the object that is being housed by that's being housed that contains all of the items. So in React, what would happen is you would update the state, and then you would create a brand new state, and so that tells the browser that it needs to update. In like you would have to do something similar like that for jQuery, but it is a little weird in Angular because Angular does catch it in this scenario, but it does not catch it in this scenario. Um, and um, and that kind of goes back to what I was saying before, where let me go back to here, when we add, if you remember, or if you saw the previous videos, whenever we add a mesh, these tables wouldn't work. And the reason they wouldn't work was because we had to, we had to create a new, this right here, this line of code creates a brand new array address. So then the table knows to update. And that is part of the problem. But it's definitely not the whole problem. Anyways, that's about it. This is a 20-minute video. Sorry about that. I just really needed to get this right in my head, and I apologize if I've wasted your time, but it's all about me. Sorry about that. Happy coding. Bye.